All right, welcome to This Explainer. Today, we're diving into one of the absolute most mind-bending, deeply mysterious concepts in all of science. We're actually going on a bit of a detective journey today. We're looking for something that sounds incredibly simple, something you probably talk about every day, yet it has completely baffled philosophers and physicists for literally thousands of years. We are on the hunt for absolute true nothingness.
To kick things off, let me ask you a question. What are you thinking about right now? Take a second, be honest. If your mind was just kind of wandering before I ask that, you might instinctively answer that you're thinking about, well, absolutely nothing.
But the really fascinating thing here is, if we hooked you up to a brain scanner, we'd see something totally different. Neuroscience reveals that your brain's nothing network, what they call the default mode network, actually uses 30% more energy when your mind wanders compared to when you're actively focusing on a task. So doing nothing actually requires a massive amount of physical effort. Your brain is a complete flurry of electrical activity, constantly analyzing past experiences and storing memories. So true nothingness? It definitely doesn't exist inside your head. But what if we look outside?
Let's start our detective mystery by looking for true emptiness in a totally everyday object, right here on Earth. Imagine we take a regular box and seal it up tight. It's empty, right? Well, not really. Down here near the ground, a single cubic meter of air contains roughly 10 trillion molecules. Plus, dust, dead skin, cosmic rays, the whole shebang. So what happens if we hook up a heavy-duty vacuum pump and just suck all the air out of that box?
Get this, even if you use the absolute most powerful laboratory vacuum on the entire planet, like those incredible vacuum tubes they use at the Large Hadron Collider over in Switzerland, you're incredibly still left with 10 billion bouncing air molecules per cubic meter. 10 billion! I mean, that is a whole lot of something. It is definitely far from nothing. And humanity has been peeling this onion for centuries. The ancient Greeks, like Aristotle, they believed empty voids were literally impossible. He famously said that nature abhors a vacuum. Honestly, we didn't even have a mathematical placeholder for nothing until Indian astronomers brilliantly conceptualized the birth of zero, or sunya. And it wasn't even until 1654 that a guy named Otto von Guericke physically proved vacuums could exist. He pumped the air out of two sealed hemispheres and famously showed that not even two teams of horses could pull them apart against the outside air pressure.
So here's the crucial point. If a vacuum box here on Earth is still absolutely teeming with stuff, what if we launch our box out into deep space, far, far away from Earth's atmosphere, way out into the dark cosmos? Is this nothing?
Surprisingly, no. Even in the absolute deepest, darkest, loneliest void of interstellar space, a cubic meter still holds about 500,000 particles. And honestly, that's not even counting the thousands of trillions of neutrinos passing right through it, or the invisible dark matter, or the constant wash of electromagnetic radiation, from X-rays to starlight, that's just endlessly crisscrossing the void.
Actually, speaking of starlight, that brings us to a really fascinating historical puzzle known as Olber's paradox. Think about it. If the universe is infinitely vast, completely static, and filled with an infinite number of stars, then every single line of sight should eventually hit a star, right? The night sky shouldn't be dark at all. It should be blazing bright, literally as bright as the surface of the sun. So the fact that the sky is dark tells us something incredibly profound about the space around us.
To figure out this mystery, brilliant astronomers like Henrietta Leavitt and Edwin Hubble came up with a step-by-step method to actually measure cosmic distances. Leavitt realized that the pulse rate of a specific type of star, a Cepheid variable, perfectly revealed its true underlying brightness. Hubble then took that exact method and used it to measure stars in what they used to call the Andromeda Nebula. He realized, wait a minute, it's not a nebula at all. It's a massive, unbelievably distant island universe of its own.
And the culmination of those discoveries revealed something just staggering. Those distant galaxies, they're moving away from us. The universe is expanding, which means it hasn't been around forever, and that is why the night sky is dark. Starlight from the furthest reaches just literally hasn't had time to reach us yet. But it gets crazier. When modern astronomers measured this expansion, they found it's actually accelerating. Our universe is mostly made up of this mysterious anti-gravitational force pushing it apart, which we call dark energy. That makes up roughly 68% of the cosmos, alongside 27% dark matter. Ordinary matter, literally everything we can see, touch, and interact with, is just a measly 5%.
Okay, so let's peel the onion one more layer. What if we isolate a tiny box out in deep space and we magically, painstakingly remove every single atom, every stray photon of light, all the dark matter, and somehow even manage to extract all the dark energy? Surely then the box is completely empty. Is this finally nothing?
Well, the subatomic world fiercely blocks us from true nothingness. According to Werner Heisenberg's uncertainty principle, which is a fundamental law of physics, the universe basically demands a certain level of fuzziness. If we trap a single particle in our box to stop it from moving, meaning we know its exact position, this law dictates that its speed becomes wildly unpredictable. It will just frantically jitter and jiggle around. You literally cannot cool a space down to absolute zero where everything just stops.
And this perfectly illustrates the huge difference between old physics and new physics. In the classical, old-school Newtonian view, the vacuum was just an empty stage, a blank geometric grid. But the quantum vacuum, it is a whole different beast. Space is not a blank theater stage. It is a restless, vibrating ocean of energy fields that overlap absolutely everywhere in the universe. Even when you scrub out all the particles, the foundational fields are still there, constantly vibrating, with virtual particles just continually popping into and out of existence right from the void.
The legendary physicist Richard Feynman really hit the nail on the head when he described just how profoundly strange and counterintuitive this quantum sea is compared to our daily lives. The quantum vacuum is a place of probabilities, not certainties. Something can literally be born right out of this empty space, because, at a fundamental level, empty space is actually something.
So if space itself is this bustling, boiling soup of something, then to find true nothingness, we have to travel beyond the limits of space entirely. We have to rewind the clock and travel all the way back to the very dawn of time itself.
Enter the Big Bang. First proposed by George Lemaitre as the primeval atom theory, the Big Bang showed that our universe had a definite beginning. It expanded roughly 13.8 billion years ago from a singularity of infinite density. We can actually still see the fossilized light of this cosmic birth today. We call it the cosmic microwave background radiation. But that brings us to the ultimate question. What existed before that singularity?
Well, because quantum mechanics allows virtual particles to just briefly pop into existence from the void, back in 1973, physicist Edward Tryon threw out this incredibly provocative idea. He suggested that our entire cosmos might just be a random vacuum fluctuation, like a fluctuation that borrowed energy from the swirling, bubbling quantum foam and just blew up to spectacular scales. As Tryon Riley put it, and I love this, I offer the modest proposal that our universe is simply one of those things which happen from time to time.
But Tryon's idea is just one of many totally mind-blowing models that physicists use to try and imagine what existed before the Big Bang. Some scientists, like Roger Penrose, suggest endless chains of universes, where the death of one triggers the birth of the next. Others propose sequential bursts of creation, or even a quantum bounce, where an older contracting universe just squeezed down and rebounded right into ours. But regardless of which model you look at, they all point to the same incredible idea. Before our universe, there wasn't nothing. There was just something else.
Okay, so if we can't find nothing at the start of the universe, maybe we'll find it at the very end. In the unimaginably distant future, trillions and trillions of years from now, long after all the stars have burned out, their energy totally exhausted, and even the supermassive black holes have completely evaporated away into quantum radiation. When the universe is just this cold, dark, ever-expanding husk. Is that nothing?
Well, no. Because even in that dead, pitch-black cosmos, the fundamental laws of physics would still be there, just lying in wait. The speed of light, the strength of gravity, the baseline energy of the quantum vacuum. These constants of nature are baked into the very fabric of reality. They're the rules of the game, and they remain in place even when all the players have completely left the board.
Which brings us to our final, really staggering realization today. To achieve true absolute nothingness, you wouldn't just have to empty the box of particles and radiation and quantum fields. You'd have to eliminate the box itself. You would have to destroy space, time, and the very constants of nature. You would literally have to destroy reality itself. And that leaves us with an incredibly provocative thought. If absolute nothingness goes against the very definition of existence, is our universe simply incapable of being empty? Does nothing even exist? Definitely something to think about the next time your mind wanders. Thanks for exploring this massive mystery with me today.